Well, greetings everyone, welcome back to the Bass Blaster Audio Tech YouTube channel. And in this video I have this thing. This is a JBL creature, but it's only the subwoofer and the amplifier part. The place I work at, they throw away a bunch of things during the summer. Well, I went out there and I seen this in the trash bin labeled to go out to the dumpster, so I grabbed it. Now, I don't have the left and right speakers, I don't have the power brick. So in this video, I'm pretty much just going to tear the thing down. I don't know anything about this. Matter of fact, I've never even heard of it until today. However, it must have a pretty good power because the power adapter for it is 18 volts at 3.5 amps. That's a little over 60 watts. So, yeah, that's it. Maybe I'll rig my DC supply up to it and play with the subwoofer some, but I can't do anything else with it, because this is all I got. So it looks like it comes apart pretty simple. We have 2 screws at each one of these corners, and so I guess I better start screwing away at these. This might take a little bit. I guess I could go over the connections we got here. From left to right we have a power indicator, right speaker out, audio in, left out, power button, AC in. Actually, wait. This 18 volts, is that AC or DC? Because it just says model creature. 18 volt, 50-60 hertz, 3.5. So let's see, 18 volts after it's rectified. That's 18 times 1.414. That's 25 volts. Wattage is voltage times current. So by the rectifier, we're going to have 25 volts times by 3.5 amps. That's an 87 watts. Surely this thing's not that powerful. There's no fucking way. This is only like a 4 or 5 inch driver in here. With that much power, this is probably definitely going to be a Class D amplifier. I was hoping I could pull out like one of those quad channel STA chip amps, or TDA. But it's probably going to be a TPA at this rate. Okay, I assume it just pulls apart. I don't think there's any screws under the sticker. Let's just try it. Now there is a foam gasket all the way around it. I can see because it's kind of leaking out a little bit here where it's like mushed. So how easy this is going to come apart, I do not know. I don't think it's too easy. It looks like it's just prying apart. Okay, these potentiometer knobs have to come off, I think. Yep, they just pull off. There's some not quite glue, but something slimy on it. Ah. Those are metal. Keep those. Oh, I gotta take this nut off. So my plans for this thing is, as of now, just to pull the guts out, keep the driver, potentiometer, any other circuitry that's in it. Because I don't really have a use for just a subwoofer. Surely not. That probably made so much noise. Let's take a closer look at this thing, why don't we? This looks like quite the board. It's fully custom, right? We got this beefy woofer here, UBL brand. Can't really see it, I'm off shot a bit. Look at this board. We have a big filter cap. What value is it? That's an 8200 microfarad. We do have some form of a chip amp down here. It's on this big piece of metal as a heatsink, which actually uses the port tube as some of the heatsink. A whole bunch of chips. I don't even know what all these chips are for. There's a bunch of JRCs. There's an LM339. I believe that's is that a MOSFET driver? No. I think that's a quad op amp. there's a whole bunch of BA 4560s. I'm pretty sure that's an op amp, but I'm gonna look that up real quick. The BA 4560 is just an op amp. Why are there so many? What is this thing doing? Like it's a double-sided board, and the lighting's not very good, but wow, look at that. That is impressive. What is all this circuitry for? This is just a 2.1 system. Look, you can see the connectors. That's all we've got. Right out, audio in, left out, AC in, and power indicator. What? I wonder what this chip is. Switching over to just a photo of the main board, so I can kind of like show you where the chips are better than I can with the camera. And of course, I'm using my desktop microphone. So let's check out all the chips on this board. We have a bunch of BA 4560s. Those are all just standard, you know, dual channel op amps. Right, now we start getting into the fun stuff. We have an LM393. This is a dual differential comparator. We go up to the LM339, which is just a quad differential comparator. We have a Toshiba TC4013. This is a CMOS flip-flop IC. Neato. We have a PTC PT2256. That is a CMOS digital volume control IC. Moving down the line, we have a JRC NJM 13600. This is a Neato. It's a dual operational amplifier. However, it has two current controlled transconductive amplifiers per channel. Kind of neat. Then on the bottom of the heatsink with the power amp, which I still don't know what it is yet, we have a 75392P MOSFET. I'm not sure what it's for, but it has a 0.02 ohm drain source and capable of 49 amps. It is possible that MOSFET is actually like a power. Now see, like press the touch button on the one of the left or right speakers and it turns the whole thing on. Now I looked up the manual for this, like I should have done in the first place. Then I found that the speakers have capacitive touch, volume up, volume down, which would explain this here. This is the volume control IC, PT2256, and I think this MOSFET is actually for like a power, because there's also a touch power button, I believe. Oh, thermal paste everywhere now. And well, this FET could very well be used as a switch to turn the unit on. I don't really have an awful lot more to say. I mean, this model is from the early 2000s, like 2003, 2004. So it makes sense that the entire inside is just basic analog circuitry. I mean, shit, these volume control ICs, you can't really find an awful lot of them anymore. Of course, a lot of things like, you know, Bluetooth speakers use them, but most of it's all controlled with microprocessor. There's still some around, of course, but they're not as big as they used to be. Lots of jelly bean logic in here. I'll probably be pulling... I'm probably going to pull all these chips out and save them. I'll probably never ever use them, but I'll have them. Right, so what I'm going to do now is, God damn, this chair is squeaky. Before that, I'm going to tell you, I did pull a subwoofer out. It's just a generic 4-ohm woofer. You know, I ran it off my IC Station TPA board. This circuit layout kind of confuses me, because how I'm assuming this chip works is it's a 4-channel with a bridge subwoofer and a capacitor coupled left and right. Well, at first look, these two caps here, I'm not in the shot at all, these two caps look like they're the output cap. Because here's our subwoofer, and it has a footprint for a connector. But if we shine a light through the bottom of the board, you can't really see it, but both pins of this go back to this chip. However, I'm not entirely sure where, you know, the left and right comes from, because this cap looks like it could be it. However, it has a star ground, which buggers off to the MOSFET. What? I have no idea how that chip works, but it'll help if I know what it is. So I'm gonna See if we can pull it off of here. It's Loctited on, but that's not going to stop anything. Okay, maybe it will, because that's some pretty strong stuff. Also, reading the user manual more, the specs are rated for the subwoofer at 10% THD, of course, 27 watts, and the satellites, I think, was 9. So that is a little more beefier than the STA 540 I have plans with for my 2.1 speakers on my computer, my daily drivers. Once I get this chip unscrewed, I have to unscrew these 2 bolts, which holds in this port. See, the port also probably acts as cooling with, you know, the air going through it. I don't know what that is, but it almost looks like the nickel plating on the screw just came right off. The nickel plating on the screw came right off. I've never seen that before. Right, take these 2 screws in the bottom out. Alright, so to get to the chip, I need to pop out this little bracket that was holding it in, which should, in theory, come right out since I took the bolts off. The nuts out. Right, here it comes. So I've got this funky metal bracket which is holding a metal plate which is hugged onto the front of this mysterious chip. Ooh. Okay, our MOSFET is stuck to the heatsink through the Loctite, which it's not anymore. Okay, heatsink is gone. I'm gonna bring the camera down. Let's see if we can make out what this chip is when I take the cover off. Alright. Moment of truth. See, it's still got the plate on it. We're gonna take out this, oh, jet. It's Philips. It is a, I can't even see it, there's not good enough lighting. Camera can't see there. This is a TDA 8512J. Let's hop over to the computer, see what that brings up. And this chip is pretty much exactly as I expected. It's a 4-channel amp, and of course can be bridged. Although it's funny, the manufacturer states 26 watts of max power, yet you go to Harman Kardon's website for the JBL Creature, and it lists 27 watts. Okay. A couple neat things about this chip. It's a Class B output amplifier, which means it's going to have very high, well, relatively speaking to like a Class AB or even a D, it's going to have fairly high crossover distortion. Never the greatest thing in the world. But I did look, and there is, here, this is how it's configured in this thing. There is output filter capacitors. However, I looked and I traced the board, and looky what I found. So pins 6 and 8 are your stereo left and right. Now how you count these multi-watt packages is the pins go 1, 2, 3, 4, 5, 6. You go zigzag. So if we do it backwards, we just do it in reverse. Alright, so here's pin 1, 2, 3, 4, 5, 6, 7, 8. So these 2 big traces are our 6 and 8 for the left and right speaker. They go over to this big pin header, which goes to this board, which had our diodes and our jacks on it. Now listen to this. This is my idea. The output capacitor is obviously in the speakers. Now remember how I said the speakers have capacitive touch on them for volume and the power? And there's, well, the speaker connectors are just a normal, 3.5 mil. My idea is the little circuit that uses the capacitive touch. My idea is the circuit for this capacitive touch is using the rail voltage that comes out of a single-ended cap-coupled output to power the touch-sensitive thing, because I doubt that circuit needs a lot of power. It's probably like an LCD screen where it's strictly a voltage-driven device. There's no current. I bet that's how that speaker, the left and right with the touch, is wired. It's using the voltage from the power amp to power the touch circuit. So here we can get an idea what our real power is. Now I do not know if the satellite speakers are 4 ohms or 2 ohms. I'm going to go ahead and assume they're 2. So at 5% THD, 2 ohms. I don't know what voltage it runs at. Assuming 15 volts, we're going to be at about 9 watts, which I think is what it's actually rated at. But of course, this chip goes up to 18 volts. So if they were running 18, well, they'd be crossing over to 12, and then into clipping, we'd be almost 20. And speakers, I think it's only rated for 7 or 9. I'd say it's probably a 4 ohm speaker. 4 ohms, 10% THD, 18 volts. Yeah, it's about 9 and 10. And there's, of course, the package. Wow, these things had some long leads on them. Well, I think I have spent enough time fooling around with this thing. I'm going to go ahead and get my iron turned on. Turn the temperature right up, all the way to 40 watts. Whatever that comes out to in a number form. Then I'm going to start pulling off parts I want. The big thing I'm going to go after is the chip, of course. Then this big filter cap. Then I'll hit the MOSFET, these caps, and then I'll attempt to get all these dip packages here. That's going to be hard to do because, again, this is a double-sided board. And, you know, solder flows all the way through. However, you know, once again, most of these pins are not flown all the way through. A couple are, but most aren't. It's a shame I couldn't get the left and right speakers, man. Wonder why they threw out just the subwoofer then. Maybe they thought they could reuse them? I'm definitely going to reuse this, but not for anywhere remotely close to the purpose I bet they'd have in mind. So about 5 days later, because I've been busy with other things, I finally got all the parts I wanted from this pulled. I'm not going to list them all off one by one, but I'm going to get here so you can just see the numbers of what I yanked out. Of course, our TDA chip. There's our switching FET. I usually don't pull diodes, but these were 3 amps and they still had leads left on them, so I went ahead and nabbed those. 3 capacitors, these 2,000 mics at 25 and our Lelon 8200 at 35. Some connectors, and of course, our speaker. Now, you know, I'm keeping all the screws, but that's just little stuff. This is just a standard 4-inch 4 ohm driver. It's actually a mid bass. It's not just a subwoofer. I ran it on my mini amp, my little TPA test amp. This actually plays vocals pretty well. Shame I don't have 2 of them. I could make a small set of bookshelf speakers or a center channel with them. Not bad at all. So, if you guys like this video about the JBL Creature 3 teardown and gutting, I guess, feel free to leave a like, subscribe, comment, and I'll catch you guys in my next video.